In this video, we're going to do some extra examples using polynomial functions. So the first one is a transformation. So we want to graph the function f of x equals negative x to the 5 plus 1. So we're first going to start by just graphing y equals x to the 5. Okay, and this graph is actually just right up here in the dashed line. So let's graph it down here. I'm gonna, because it's so small, I'm gonna make two things equal to a step of 1. Okay, so that's like that. Okay, so the graph goes through 0, 0. It has a point at 1, 1 and a point at negative 1, 1. And then it increases super fast and then really slow to get to 0. And then it goes slow, and then like that. Okay, so that's our graph for x to the 5. Okay, now our next step, we want to do the negative. So it's going to be negative x to the 5. So this is going to be a reflection in the x-axis. Okay, so here I guess I had points 1, 1, 0, 0, and negative 1, 1. Negative 1. So when I reflect in the x-axis, 0, 0 is going to stay, but 1, 1 is going to become 1, negative 1, and 1, negative 1, negative 1 is going to be negative 1, 1. Okay, and then the graph is just flipped. So it's going to, look something like that. Okay, so it goes through 0. I didn't draw that very well. Maybe I should try again. Around the middle here. So it goes through, and now it's on this side going slow. Okay, so something like that. And now I want to add the 1. So now I have negative x to the 5, but plus 1. Oops. Okay, so this is going to shift the graph up 1 unit. Okay, so now instead of at 0, 0, I'm going to be at 0, 1. Okay, negative 1, 1 is going to be now at negative 1, 2. And 1, negative 1 is going to be now at 1, 0. Okay, so we just shift it up. Okay, it comes down. Oops. Flattens out at 0. And then increases or decreases very sharply. Okay, so that's our final graph there. So that's how we do transformations. Okay, so work the same as they did before, just we have more graphs to work with now. Okay, so let's look at example 3 here. So we have the function 2x cubed times x minus 1 squared. We want to find the roots, their multiplicities, and then determine if they cross or touch the x-axis at their x-intercept. So to find the roots, we want to solve f of x, or sorry, not f of x, 0. We want to set f of x to be 0 and solve where f of x is equal to 0. So that's going to be when each of these bits is 0, so this bit is 0 or this bit is 0, the 2 can't be 0. Okay, so we have two different factors. Okay, so I have x minus 0 is a factor. Okay, because of, maybe I'll use a highlighter here. So x minus 0 is the x there. That's like x minus 0. Okay, so it is a factor. So that means that 0 is a root, okay, or 0, and it has multiplicity equal to 3 because that's the exponent on the x on that factor. Okay, so now multiplicity 3 means that the graph, because it's an odd multiplicity, the graph is going to cross the x-axis at x equals 0. Okay, so we're going to cross there. Now the other factor we have is x minus 1 is a factor. So that means that 1, or x equals 1, is a root, and this one has multiplicity equal to 2 because of the exponent. Okay, now an even multiplicity means that the graph touches the x-axis but does not cross. Okay, at x equals 1. Okay, so let me just write here, so not cross. Okay, it touches the x-axis and then bounces back up. So those are, so x minus 1 is a factor because of, oh, I guess I should do them in the same spot, because of this factor here, because they give it to us in factored form. So that is, so you just want to look at whether, so this one multiplicity is odd, okay, so that's why it crosses. This multiplicity here is even, okay, so that's why it just touches. Okay, let's try another one. So this is about end behavior. Okay, so we want to find the leading term here so that we can find its end behavior. So for the leading term, we just want to take each of the leading terms from each factor. Okay, so that's going to be the 3, the x from this one, and then the 2x squared from the third factor. Okay, so I'm going to have 3 times x times 2x squared. So that's going to give me a 6, and we're going to have a 6x cubed. Oh, sorry, this one is actually cubed. I missed the power there. So because of the cube here, we take the x, but we still have to cube it. Okay, so that's still going to be a 6, but now I have x cubed times x squared is going to be x to the 5. Okay, so that means that the degree of this polynomial is going to be 5, which is odd, and the leading coefficient is equal to 6, which is positive. Okay, so that means that our end behavior, so it's an odd one, so that means it comes and leaves in different ways, and it's positive, so it's the normal one. So our end behavior is going to look like that on our grid. Let's try another one. So here we have the function f of x is x cubed plus x squared minus 12x. And we want to sketch the graph by finding the intercepts and determining the end behavior. So the first thing we might want to do is put it in factored form. So I can factor out an x, and then I'm left with x squared plus x minus 12. And now I can factor this quadratic as x plus 4 times x minus 3. Okay, so that means that I have, and they each have multiplicity 1. Okay, so I have roots at x equals 0, x equals negative 4, and x equals 3. Okay, all have multiplicity equals 0, which means that they all cross the x-axis. Okay, so I don't have to worry about that. And then the degree of f of x, I can see from the original, okay, the degree is 3, and the leading coefficient is equal to 1, which is positive. So that means that my end behavior looks like the last one. So it looks like that. So it's odd with a positive coefficient, so we get that end behavior. So if I just plot my points, so I have a point at 0, 0, so the x-intercepts, so these ones are all x-intercept values. So then I have 1, 2, 3, negative 4, and positive 3, and they all cross. and I know that it leaves that way and leaves that way. So that's enough to sketch. So it's going to cross, come up to some point, okay, cross again, down to some point, and then cross again, and then leave like that. So our values are all, and actually I should have found the y-intercept as well, but it turns out that it was, because our x-intercept was 0, the y-intercept is also 0. Okay, but that's what our graph would look like. Okay, we just have a couple more to do. So let's consider this function. Again, we want to sketch the graph and label the x and y intercepts. So we want to find the intercepts. So let's find the y-intercept. Okay, so that's going to be g of 0. So I plug in 0. So I'm going to have negative 1 over 8 times 0 minus 2, so minus 2 squared, times 0 plus 1, which is 1, times 0 plus 4, which is 4. So that's negative 1 over 8. Negative 2 squared is 4. Okay, so that means that g of 0 is going to be negative 16 over 8, or negative 2. So I have a y-intercept of 0 and negative 2. Okay, so we could plot that. Okay, so now for my x-intercepts, okay, it's given to us in factored form, so we just need to look at the factors. Okay, so x minus 2 is a factor, which means that 2 is a root or a 0 with multiplicity equal to 2. Okay, so that means just touch. Okay, now x plus 1 is a factor, so that means negative 1 is a root, and here it has multiplicity equal to 1, so that one is going to cross the x-axis. And then we also have x plus 4 as a factor, so that means negative 4 is a root or a 0. Okay, and it also has multiplicity equal to 1, so it's also going to cross. So I can put these in, so I have at negative 1 and at negative 4 and at 2. Okay, so I have those values. And then we want to think about the end behavior. Okay, so we want to get the leading term. So I take the leading term of each piece. So I'm going to have the negative 1 over 8 from the first piece, and then I have the x from the second one squared. Here, let's highlight those. Okay, so negative 1 over 8 is there, and then I take the x from the second piece, and then I want to take the x from the third piece. Okay, and that's going to be just x, and then also the x from the fourth piece, and that's going to be that x there. Putting all that together, I get negative 1 over 8 x to the 4. So here, the degree is going to be 4, which is even. Okay, and the leading coefficient is negative 1 over 8, so less than 0. Okay, so that means that my end behavior is going to look like that. Okay, so I know that it leaves like that. Okay, and that's enough to do a rough sketch. Okay, so I go through, so I have my negative 4, 0. I have my negative 1, 0, my 0, negative 2, and then my 2, 0. So I cross at negative 4. Okay, so I cross, I go up some amount, I don't know how much, and I cross at negative 1, I go to the y-intercept. I don't know if I cross or not. Okay, so maybe I cross, but then I come up, I just touch this x-intercept, so I don't cross, and then I come back down. So my graph would look something like that here. So that would be the graph of this function, or a sketch. So we don't know how high these peaks are, where they occur. Okay, so we can find that. Calculus sort of helps us find those type of information. Okay, example 8, one more. So here we want the equation of a polynomial whose graph looks like this. Okay, so here notice I have an x-intercept at -3, 0, and it just touches. Okay, I have an x-intercept at 0, again, just touches. And then I have an x-intercept at 1, 0, and here it crosses. Okay, so then I have roots. Okay, so x equals -3. Okay, and it's going to have even multiplicity because it just touches. Okay, x equals 0 also has even multiplicity because it just touches. And x equals 1 has odd multiplicity. Okay, so that means I need to have factors x minus -3 or x plus 3. Okay, and it has to be to an even power to have even multiplicity. And then I have x minus 0, or just x, okay? Again, has to be an even power, okay? And then I have x minus 1 as a factor, and this has to be an odd power because it crosses there. Okay, so also we know from here, so the end behavior, it leaves that way and comes like that. So the end behavior we know that the degree has to be odd in total, and that the leading coefficient has to be positive. Okay, so putting all that together, I could have f of x, so I could describe this with, so I need to have x plus 3, and I need to have it to an even power, so maybe to the power 2, and then I need to have x minus 0, or just x, also to an even power, maybe it's 2, and then I need to have x minus 1 to an odd power, okay, maybe it's 1, maybe it's 3, doesn't really matter. And my leading coefficient, because I've just done them all x's like that, the leading coefficient is going to be this term here in front. Okay, so maybe I have, oh shoot, sorry, I did this wrong. Oops. The a should actually be less than 0, right? It should be a negative number if I go that way and leave that way. Okay, so I need a negative number out front. So, I mean, you could just put a negative. Okay, that would be an example of a polynomial that looks like this. Okay, or a different, there's many you could do. So maybe you have -5. Okay, we don't know the height. There's no grid on the y-axis. We don't know how tall it is. Okay, so maybe I have -5. I have to have the x plus 3, the x, and the x minus 1. Okay, and these ones have to be an even power. Maybe x plus 3 is to the power 4. Maybe the x is to the power 10. Okay, x minus 1 maybe is to the power 13. Okay, as long as this number out front is negative. Okay, these two numbers are even because those ones have to have even multiplicity. and this number has to be odd. Okay, then we will satisfy, and we have obviously these three factors. Then we will satisfy the properties that we know about this graph. Okay, so there's many different examples here that are correct.